Hello, good YouTubers and students. Welcome to part 2 of my persisting Redux state or hydrating Redux state series here, where I go over a couple different options on how to do so, and some are better than others, like I said in the first video. So this video is second in the series. So if you're wondering why I already have a boilerplate starter ready to go, I actually code this whole thing out and discuss my choices and options and why I write it the way I do in the first video, which I'll make sure is linked in the description below. That way you can go watch that video, see how I coded the starter, and see my first hacky solution in that video that hydrated or preloaded the state asynchronously, which seems to be a common question that I came across that didn't have a lot of great answers online, at least not without doing some intense digging, which, you know, as developers, we're all used to doing, and finding Stack Overflow posts from 2016 that has something even tangentially related, and you're like, I can use this. If I can use this. Been there, man. Been down that rabbit hole too many times. So remember, go watch the first video if you have no clue what's going on or want to know just how the starter was built up. I'm going to be using the starter, which I already have cloned. I have all my dependencies ready to go and installed. It's very simple, and it has like a little fake full stack create React app thing going on by running a server in tandem with my create React app to quote unquote save our state. So in the last video, I made something called configureStoreAsync, and I told you that it wasn't my favorite solution, but it got the thing working. It asynchronously hydrated the store with some preloaded state that was saved to our server, which again, you will typically see things online that just serialize it to local storage. That way it acts synchronously, and then it can be read and parsed synchronously and preloaded to the store, right? And it was done via that preloaded state object property right here. We're not going to be taking advantage of that this time. We're actually going to be doing a different trick in the case of this project here. So I'm going to go ahead and get things running. Let's go ahead and do what I've been doing, where I have the server and create React app running. I'll run the server on bottom today if these windows want to actually move. Come on, stop it. I'm going to run my server down yonder. Persisting Redux starter. npm run server gets the server up and running. There we go. This needs to npm start, so we get my create React app up and running. And while it does that, make sure to like, comment, and subscribe. Helps us on the YouTube channel here, keeps me engaged and happy knowing that people are watching this and asking questions and learning things from it. And also check out the links below in the description if you're curious about how RTK or Redux and the other things work. I have a full React course available on Covalence that you can purchase as well. Okay, so up and running. You know, I have no logic at the moment to say. I mean, I have saving state logic on the server, but at the moment the starter doesn't have any kind of logic to bring that data in. So at the moment I don't have even like a store subscribe to remember the state between hard refreshes. Okay, so that's probably one of the first things we're going to tackle, and it's actually fairly straightforward to do so. It's going to look very similar to my solution last week, but because the store is now synchronously created, I don't have to do any kind of weird promise wrapping functions like I did in the first video of this series. I can simply say, hey store, I wish to subscribe to all state changes that you have to offer. And what I would like to then do is simply run the following code. Get some state, we can say store.getState, gets the current state of the store on any state change. And again, we can demo this here in our browser by simply console logging that value, and check it out. Every single time I make a change, something is being console logged that represents the current store state right behind my fat head. I can actually zoom in to make sure y'all can see that. There we go. So I'm talking about. So we got that. I had that bad habit of using so as one of my segues between sentences and thoughts, don't I? I just noticed that. You notice a lot of things about yourself when recording. You learn much about yourself when staring at a camera, talking to nobody for hours on end. Anyway, we're going to say fetch to /state. Remember in the first part of the series I talked about where we don't have to write the full location of the server, which was localhost :8080 /state, because I have it running with this cool proxy property in the package JSON, which I explain more in the first video. The method, nope, just kidding. The method of this is a post request. The headers of this request simply need to indicate to our server that it has a type of application JSON. That way our JSON body parser, new band name called it. Ooh, that's a good band name, body parser. Body JSON stringify the state that we get from our get state. And then I don't care about handling errors because we're not going to have any. And we'll say this is the server response, and we'll console log this server response every single time this store.subscribe updates the state and tells our server what's going on. So I'm talking about, y'all. Okay, so we're saving, there it is again, that word. So we are saving state fine to our server, but at the moment we have no logic to retrieve that state on a hard refresh, or for example, a user logging in for the first time, or logging in on, imagine our user logging in on a different browser. There would be no logic that says, if they logged in from a different browser, they've already loaded the app, which is the downfall of last week's solution. Or not last week, it doesn't matter who went last week. Last video's, there we go, solution, where I had a configureStoreAsync that would simply wrap the index root render out here in a promise to say, load the app after the store is configured asynchronously. That means on hard refreshes or fresh visits or incognito visits, it would still be able to get the state from the API, configure the store with it with preloaded state, and then finally load the app in the browser. But the student I was answering a question for in our Discord about how to do this immediately ran into the case going, well, what if one of my players of my game logs in from a different browser and wants to retrieve their save state? Well, that already breaks last video's solution, because by the time they get to a login screen on their app, it's already rendered the app and pre-configured the store with default values. So we had to come up with a solution that would then say, after they log in, go and fetch that state from the API and somehow dispatch a singular action to update everything. This individual student had 25 different slices of state. So we would actually have to dispatch 25 dispatch functions and action creators to technically update the store to those saved values from the API. Now, while they weren't stoked on doing that, there was actually a cool solution that we came up with during a webinar together. And I thought it was particularly clever, and like I said, I found a tangential example of it from a 2016 post written by Dan Abramov himself, and I basically just took it and twisted it to work for what our purpose was. Go figure, right? So, there it is. Oh my god, I said it again. Anyway, here's what we ended up doing. We need a way to be able to dispatch one action that totally updates our global state. Now, in their case, it was 25 different slices of state with many, many sub-properties they had to worry about. But in our case, it'd actually be pretty simple to simply come here and add a action to our reducers that said, update state, or use this, or something like that, right? We can add a action to both of these pieces of state here, these slices, that simply brings in that says take the current state and assign it to the action payload, right? So we can do something as simple as state action state equals action payload. That's all you would need to do to say use this state that's coming from our API call. And again, in this example, coding one for each of my slices and just simply dispatching both updates individually from my API response would be pretty simple. But when you have a large and real-world Redux store, that's probably not going to be the case. It's going to be very difficult to parse all that data from your API into 25 or more parts and dispatch 25 actions to the store to say use all these states. So here is the solution, the big brain solution that covers the use case and can be used all across your app if you want to. What we're going to do is we're going to rename this as the app reducer, because that's what it represents now. It represents the actual app's state. Now, does it really make a difference if I call it root reducer or pizza for that matter? No, it doesn't. So what I'm going to do is I'm going to now make a new root reducer. And remember, a reducer is nothing more than a function that takes two arguments, state, action, and returns a new state based on that action. That's all it is. That's all reducers are, and I teach that and so much more in my course if you're interested in learning the ins and outs of these things. So if I return app reducer, which is a function that takes state in an action, I'm basically daisy chaining this root reducer to the core app reducer now. So in my configure store, there it is. See, I notice that word all the time now. Root reducer. All I've done is I've created this, not middleware, but this kind of like wrapping root reducer around our app reducer. And I'll prove to you that that's all this is, right? It wraps our app reducer and just has it function as normal. Nothing has changed about our store and our Redux and React Redux code. It works exactly the way it should. Nothing has changed. Interestingly, what if we wanted to pass in a custom action to do something? Well, here's our next test. And remember, the actions are just objects at the end of the day. If the action type is, for example, something like hydrate or use this state, let's have it console.log a phrase such as here. You know, this is real development debugging. No breakpoints, nothing like that. Nah, man, we console logging the word here to know if we're inside of an if statement. That's my favorite debugging tool on planet. It will never not make me laugh and smile when I see individuals, no matter how experienced or inexperienced, default to tricks like this to see if things are working the way they think, right? So while we got this going here, let's go back to the browser and check it out. You know what? I don't have a button that will dispatch that action, so it's never going to work. Whoopsie. So we're going to head to our app.jsx. We're going to add some arbitrary div down yonder with a bouton element that says hydrate. And it's going to, in onClick, run a function that will then dispatch or call the dispatch function. And up until this point, we've been calling action creators for our RTK code. But remember, an action is just an action creator is an object that returns an action. Technically, that's not wrong because functions are objects. But what I meant to say is action creators like login, logout, add, sub, reset. Those action creators are nothing more than functions that return actions, and actions are nothing more than objects. Objects who typically, in RTK's case, have to have a property called type whose value is a string. So if we're matching an action type of hydrate, this button should do so. And check it out. It recognized that we dispatched an action to the store. That's what I'm talking about. Okay. That means we can also carry in some kind of payload to our store. Let's just do an arbitrary coded 5 on this payload here. Head back to the store and console log here and our action.payload to see what happens. Booyah. Right? It logged here 5 and it recognized that we passed in an action payload. Okay? Well, look at the code down here on 17, currently line 17, that says app reducer state action. This simply daisy chains our current store state, whether it's our defaulted values or otherwise, into our app reducer, which goes to our individual slices. If they aren't given a state, they have fallback initialized values that we coded into our create slice functions in the previous video. That means that I could pass in state here at the root reducer level that could be able to be passed down to my app reducer for my reducers to use it. What do I mean by that, right? I mean, saying that out loud does sound kind of weird. So maybe an example might help. Take a look at my count state. What does it look like? It is an object with a property value with a value of a number, currently 0. So what if on my hydrate dispatch, my payload was an object with a property? Is that going to work? Now I think about it. I mean, I could pass in the whole thing. I would need to be an object, which would represent the whole state. Or check this out. Let's just make it an object with property count. There we go. With property value and have it be 5. So what we're doing here is we're passing in an object with a property of count whose sub-object is property value with a value number of 5, meaning this technically represents the count state. Now, it doesn't represent my whole state, right? Because it's missing, what's it called? The auth piece of state from my app reducer, right? Because the app reducer does have another part here. But RTK is smart in that it can actually merge state objects together. So even if I don't include auth in my hydrate here, it will just default to whatever auth defaults to, which I think is like a logged in of false, I believe is what it defaults to. So what I'm trying to say here is rather than just console log, why don't we say we return our app reducer, pass it in the action payload as a state to use, and just pass in and daisy chain that action down the line to make sure nothing gets broken, right? So we're saying return our app reducer with an action payload of what we're passing in, which we saw was basically my count state. And check that out. It didn't mess and break my auth state. We can go to our Redux dev tools, which, and if I didn't talk about this, oh, I'm so zoomed in. If I didn't talk about this in the previous video, you have to install these from the Chrome web store, so make sure you go and find Redux dev tools in the Chrome extension store, the Chrome extension place, and then install it to make sure you can view this. RTK comes by default with a configured store that includes the dev tools. But check it out. It updated my count Redux state to value 5 and didn't break. It correctly took the object and merged it in without losing the auth slice. I think you can see where this is going. If I wanted to now, I can also pass in another property called auth with another sub-object of logged in, and we'll make it to true. There we go. So this button should technically hydrate my store to whatever I want it to be. Let's check it out. I'm going to do a hard refresh. False and 0 again. Hydrate. And it takes those values and it knows how to apply them to those states. So rather than doing this with a button click, why don't we just run a request to our API? So what I'm going to do now is I'm going to come up here and add a use effect from React, and we're going to do a little mini data fetch. We're going to say in the use effect, run the following code only on page load. So remember, the empty array means after the initial render only, when this code should run. I'm not going to make this into a thunk. I'm going to instead just kind of do an old school way here. And if there's interest in learning how I can convert this dispatch into a Redux thunk, leave comments below and let me know, and I'll happily make this as an addendum to the series, where we make a request to state. It's a GET request that will then take the response, and regardless if it's good or bad, try and parse the JSON data that comes from it. Then we have the preloaded state data that's saved, or we can call it saved data, that I then wish to dispatch an action type of hydrate with a payload of saved. And there we go. That should do it. So on page load, it's to take whatever's in the state and save it, right? So let's check it out here. I'm going to hard refresh the browser. I think nothing is saved in my server as of yet, so let's see what happens if let's just change it up here. We'll do 7, login, looks good. Hard refresh. Well, that's peculiar, isn't it, folks? Why isn't it not doing what I thought it should do? Fetch state, it's a GET request. Let's see, let's just console log saved and see what's coming back here. Oh, that's peculiar indeed, isn't it? I don't think I messed something up. Yeah, it's coming back with values. It's there. So what am I missing here? What did your boy mess up? Oh, dead air. I love having dead air on a video like this. But, I'm a proponent of leaving in mistakes and errors and trying to talk my way through them to see what piece of the puzzle I'm missing. That way, y'all can also feel like you're learning something from these values. Interesting. No, it's definitely dispatching it correctly, but it is not updating the state correctly, is it, folks? Interessante. All right, so it's passing the payload in correctly. Payload saved type. It's not, I can't point my finger at it. I made a typo. This is also why it's recommended to use action types like this. Hydrate. That way I don't make mistakes. Typos. This is also why individuals like action creators, which again are just functions, that will take some kind of argument that will then I'll do an implicit ES6 return that will return the action type correctly for me. And payload data. Now, you know what? We're going to do this as EX6 possible. So payload, and voila. There is our lovely action creator, and we can replace this, boom, and simply invoke the action creator and pass in that saved payload into it and go back to a nice ES6 shorthand again. Unbelievable, folks. This is like old school Redux patterns that RTK builds automatically for you. Again, I have a course that teaches all this. So I can't believe I made a typo that just brought me down. Well, now it's saved to reset all this stuff, right? So hard refresh and voila. We got there, y'all. So there you go. Mistake made. I can't believe I made a singular typo that is what brought me down. But when my eyes caught onto it, I'm sure my face was funny. Get in the comments if you've had a similar experience as me, where one little letter is what brought an entire app down. And let me know how long it took you to solve it, because I've had some bad ones. And as a teacher, I've seen students have some bad ones that I caught pretty early on and tried to like lead them to water, so to speak. And it was pretty funny. Their responses when they were like, "You mean I wasted an hour and a half because I forgot a / I didn't notice in a string?" Welcome to development, buddy. But yeah, there you go. Now, the caveat to this is you can kind of see, hopefully the recording picks it up, is that you see a flicker because the initialized slices will be 0 and false. The initial render in React happens always, no matter what, and then effects are consequences of renders. So we get our initial render with the initialized 0 and false values of our state. Then the use effect fires, it fetches, parses the JSON, dispatches the action, hydrates the store, and boom, you get that flicker. So we could make a better fetch request, meaning we can make a thunk that has states of idle, pending, or loading, and completed or errored, right? So we can actually have some hydrating states telling that we can use from our useselector that return like a loading screen until this is then completed. So there's some tricks you could do around that. And again, if there's interest, let me know. This video series is more concerned about the tactics of how to, or the logic of using and hydrating and persisting global state to our Redux stores, and not so much on like little app UX and like nuances like UX and things like that. But again, if there's interest, just let me know and I'll continue this video series or make a similar tandem video series that covers like edge cases like that flicker we see there. But again, you can handle that with even like a local piece of state that will toggle from false to true in this use effect as well to handle the loading period to make sure you don't get that flicker. But there you go. This is again, last week's solution was hacky and came with caveats. This one has its own caveats as well when handling loading states and things like that. But this is a far more Redux style solution, and considering it took and ran with a concept that I found from Dan Abramoff from 2016, I think it's a pretty good solution and much better than last week's. But again, if it works, it works. And that's always been the most important part I teach my students early on, especially when you're learning, right? You can't always try and go for the optimized solution when you're first starting out, or even like a middle level dev. You got to get things working, and then you'll learn about the edge cases and optimizations as you go. So yeah, that's it for this video, and I hope y'all enjoyed it and watch me lose my mind on this right here, on having a typo. Can't believe I did that. Me getting angry at myself for saying so too many times, and hope y'all enjoyed it. Yeah, so ta-ta for now.